All right, today we're going to tackle a math problem that honestly looks like it was designed just to be confusing. But what if I told you that the key to solving this whole thing is just one simple idea? So stick with me, because we're about to turn this complicated mess into something that's actually surprisingly simple.
Okay, so here it is. At first glance, you see different roots, different powers, all tangled together. The question is asking for the value of a over b, but try not to get lost in all the algebra just yet. The best way to look at this is to think of it more like a puzzle, and, every good puzzle has a key. And let's be real, it does look like a mess. That mix of square roots and cube roots and different powers, it's meant to be intimidating. But here's the thing with puzzles, right? It's not about brute force. It's about finding the hidden pattern, that one simple rule that makes all the different pieces just click into place.
So, to find that pattern, we need the right tools. But hey, don't worry, you're not going to need a giant toolbox full of complex formulas. For this problem, it really just boils down to one powerful idea. Let's open up the toolbox and see what it is.
And here it is. This is the key to the entire puzzle. Any root symbol. I don't care if it's a square root, a cube root, any root at all. It's just another way of writing a fraction as an exponent. The rule is always the same. The power, that's your numerator, the number on top. And the root, that's your denominator, the number on the bottom. Seriously, this one idea is going to unlock the whole thing for us. Yeah, this slide shows it perfectly. On the left, you've got the square root of x. On the right, you have x to the power of 1/2. They mean the exact same thing. It's kind of like two different languages saying the same thing. And once you know how to translate, the problem gets a whole lot easier to deal with.
That's the big question, right? Knowing the rule is one thing, but using it, that's where the magic really happens. So let's take our golden rule and put it to work on this problem. Okay, so let's do this methodically. No guessing games. We've got a clear blueprint that's going to take us straight from this complicated-looking puzzle to a simple, clean answer. And here's that blueprint. Super simple, just 3 steps. First, we'll translate the top part of the fraction. Then, we'll do the exact same thing for the bottom. And finally, we just clean up whatever's left. So let's get started with step 1. Let's put our rule into action on that top part. Okay, so the power is 5, right? That becomes our numerator. The root is a square root, which, just means a root of 2. So that 2 becomes our denominator. And bam, just like that, the square root of x to the 5th is now x to the 5/2.
Now let's do the exact same thing for the bottom. The power is 4, so that's our new numerator. The root is a cube root, so that's a 3, and that's our denominator. So the cube root of x to the 4th is simply x to the 4/3. See? The pattern is consistent. It's predictable. And this is a great moment. Seriously, take a second and look at what we did here. We took that crazy, messy expression and just translated it. Now, instead of all those different roots, we have a clean division problem, and everything has the same base, x. This already looks so much better. All right, we are on the home stretch now. The really hard part, the translation, is over. All that's left is a little bit of simple arithmetic to get us to that final answer. So to simplify this, we just need one more little tool from our toolbox. When you're dividing powers that have the same base, in our case, it's x, it's super simple. You just subtract the bottom exponent from the top one. So if we apply that rule, this is what we get. I mean, look at that. This whole complicated thing has boiled down to just subtracting one fraction from another. 5/2 minus 4/3. That's it. That's all we have left to solve. Okay, now we just have to solve this little fraction problem. To subtract fractions, you need a common denominator, right? Well, for 2 and 3, the easiest one is 6. So we turn 5/2 into 15/6, and 4/3 becomes 8/6. Now the subtraction is nice and easy. 15 minus 8 is 7, so our final exponent is 7/6. Can you believe that? That entire original expression, with all its roots and powers, simplifies all the way down to just x to the power of 7/6. Okay, so we've got our simplified version, x to the power of 7/6. But let's not forget what the original question actually asked. It wanted the value of a over b. Well, if you compare our results to the form they gave us, the answer is pretty obvious. And there you have it. A is 7, b is 6. The final answer is 7/6. We took that intimidating puzzle, and by using just one simple rule, we found a simple, elegant answer. That's what happens when you know the fundamentals. So you might be thinking, okay, cool, but why does this really matter? Well, it's about so much more than just this one math problem.
It's really about a way of thinking.
What we just did shows a really powerful idea. It's about having the right tools in your mental toolbox. You can take things that look super scary and complicated and reframe them into something you can actually manage. And this specific key, knowing that roots are just fractional exponents, is absolutely essential for everything from algebra all the way up to calculus. It's the power to see simplicity hidden inside of complexity.
And really, that's exactly what we did today, isn't it? We stopped seeing a random collection of symbols and started seeing a simple, repeatable pattern. And that right there is the real beauty of math.
And a quick credit for this awesome puzzle goes to the source on your screen. Hey, thanks for hanging out with me to break this down. I hope this helps you see patterns where you used to see puzzles. I'll see you in the next one.